Morning. So today we are here to discuss about a deep reinforcement learning technology. So before getting into it, let us discuss with a session with a brainstorming session. So let us take a situation. Can you tell me where the reinforcement learning is implemented?
Yes, ma'am. I'll give you an real life scenario and we'll discuss about it now. Let's imagine a rescue bot entering an earthquake attacked building. The bot needs to understand the environment because the environment will be changing rapidly because the debris will be falling down. The path is not clear and it needs to find the people who are around it now. So the robot must find the survivors, avoid debris and navigate through the hardest part equally. And thinking about the complexity, the paths are really complex and we cannot even tell the robot that it should go in a proper way. There will be some stones over there, the sticks over there, so that it needs to understand the surroundings and work on it. And obstacles may come unexpectedly because in an earthquake zone, sometimes the roof will be falling at the time when the robot is moving. So it should properly analyze all the environment and work accordingly now. And humans learn through the experiences, right? We know we try and we if we find any problem we correct it. So the same thing is the robot should do to navigate through the path and help the peoples there now. And the machines should also work on the same way, trial and error and rewards and penalties, and we can also say continuous interaction with the environment. And the deep reinforcement learning will be mostly used in autonomous robots and self-driving vehicles, smart drones and all.
So Sukita has covered all these examples exactly. So these are reinforcement learning based applications. So deep reinforcement comes when the problem arises, right? A challenge where a robot has to take a self-decision in a dynamic environment. As she said, a rescue robot. A rescue robot works in a dynamic environment. It cannot predict the environment. If we are sitting here, we can predict the environment as of 50 to 60% accuracy, right? But if it is a rescue building, if there is a fire accident in the building, we cannot predict where or what damage it may happen in the next second. So the robot will be in a dynamic environment and it has to take a decision with an optimal solution. So depending upon this challenge, can you define what is deep learning?
Yes, ma'am. Traditional programming approach struggles because real-world environment constantly changes. There are too many possible situations. Fixed rules cannot handle the situation uncertainty, and deep reinforcement learning addresses this by enabling machining to learn more interaction, improves over time, makes sequential decision intelligently. This belongs to the field of deep reinforcement learning.
Very good. So depending upon this deep reinforcement, what we can develop from this?
Yeah. Reinforcement learning is inspired by behavioral psychology. An intelligent agent interacts with an environment. An agent takes action, receives feedback, learns better strategies over time. Agent 1, a learner, often a decision maker. Example, robot, drones, self-driving cars. The world where the agent operates, disaster zone, warehouse, traffic system. The current conditions of the environment, the robot positions, sensor readings and observing locations, and actions will be taken by the discussion taken by an agent, move forward, move left and pick an object like that and all. Feedback received after an action, positive rewards for successful, negative rewards for collision.
So the next stage, we have an idea now. So what will be the next stage with this algorithm?
In the prototype stage, right? Let us design a DRL based warehouse robot. The robot must deliver the package and avoid obstacle and find shortest route to operate efficiently. Like environmental initialization, virtual warehouse is created, like sleeves, obstacles and delivery points. Then observe state. Observe states like camera, lidar and ultrasonic sensor. And then take action like possible actions includes move forward, turn left, turn right, and receive rewards like 10% and for 5 minus 1 and like that. And learning process like the robot update the neutral and network based experience. Initialize, the robot makes mistakes and conditional frequently, and many training episodes navigate, improves, and decision making. That's all.
So deep learning is nothing but a part of reinforcement learning. So this is the exactly placed with an award system, penalty and award system. It learns, it gets award or penalty. Depending upon it takes the next step decisions. So now we will close this, and in next video we will discuss with that case study.